Hi, this is Fred with Sean running the camera. We wanted to show you the bearings that we got for the 94 4Runner. That we're replacing the bearings on the rear carrier, which I will show you that in a moment. But the actual bearings we got them down at Napa. It was like $56 for the bearing. It is a BR140. They're SKF bearings numbers. And we got the seals for the rear axles that are Napa SKFs again here. They're 19630. They were like $8 a piece. These were the actual part numbers that were on the original race and bearings. And if you can see those, that will maybe help you find the correct bearings whatever brand you may have in your area. The seal number is this AB2853F, and that was by the brand name NOK. Okay, so now we'll show you our setup on the bearing install. Okay, this is the rear differential carrier bearing, and how we're going to press that onto the new carrier. We're going to use a 3/4 inch drive. This happens to be a 1 5/8 diameter 3/4 inch drive socket, which fits on the inner race. So we're going to use that here on our 12-ton press. And the reason for this is you want to be able to have the socket that fits on the inner race where there is substantial material. You don't want it on the outside race because you'll ruin the bearing. So you got to be here where this part is going to press on to the outer diameter of the Yukon Grizzly differential. So we'll do that next. Okay, one thing that's important when you're doing your setup to press a bearing onto the differential carrier, that you want to make sure it's as level and as square to your rod that you're using as possible. So I used a level here. It could be more precise if you wanted to use calipers and make shims to go all the way around exactly the same. We're doing it here kind of a backyard method, but it's still pretty accurate. We've got the bearing set on there, and we have used this little level to try to use the bubble to get it where we want it after we check the level of our surface here that we're working from. So we check it at 90 degrees, and then again at straight from what we started at 90 degrees from the starting point. So we've got that set up. So now we're going to put our 3/4 inch drive on the inner race. We're using a Harbor Freight 12-ton press. It should do the job. And we'll lock the cylinder so we can get our action from the press. We want to make sure that our race is free. Okay, we've pressed the first bearing onto the shoulder, all the way to the shoulder, so it has to bottom out so you know that it's all the way onto the differential carrier. Okay, we'll undo our setup and we'll turn it over and get ready for the other side. Okay, so I wanted to show you that we do have the bearing all the way on. The inner race is all the way down on the shoulder of the carrier, and it does turn freely. Now what we're going to do, we're going to flip it so this side is down. It fits in our hole on our setups here to where we can get this side on. And we'll try to here again to get it as square to the rest of the machine as we can. Okay, we're in our initial setup to press the bearing on the other side. I wanted to show you that the bearing race does turn freely, so we are only on the inner part of the race. The other thing is, don't use any lubricant when you're pressing these on the shoulder of the differential. So now we'll go ahead and see how we can get this pressed on here. Okay, one of the other things that we want to show you, maybe you've already heard this phrase, but it's cleanliness is next to godliness. And when you're assembling critical parts like this, that's true. One of the things we're going to do is we're going to take a fine-tooth file. A 6 to 8 inch one is probably plenty good, but what that does, what we're going to do now is we're going to check this for any high spots, make sure it's good and clean. And we're just going to go over it easy and make sure that if there's any spots where it might drag, that you keep going over there till it feels real smooth and there's no drag on the file. And that way we know we've got as flat a surface as we possibly can have with this ring gear. We've done some already prior to this just to check it out, but we wanted to show you the method and what we're doing and the importance of it. Okay, we're continuing on with our ring gear installation on the new Yukon Grizzly locker. And what we've got here, we had the differential sitting actually the other way on this. This is some of the packing from the Yukon Grizzly, made a good platform to work from. So when we had it up this side down, we were able to put the ring gear on, and we tapped it with the wooden handle of the hammer till we got it down to where the fine threads of the ring gear bolts would catch it on one side. We only put it in like a couple threads, that's all we needed. Then we went around the other side and tapped it down some more. Then we turned it over and we were able to catch another bolt or two on the opposite side and pulled them down, and then we worked it to where we got it even so you can see our gap here. So now what we're going to do is finish putting the rest of the bolts in, and you may only have to turn it a quarter of a turn to a half a turn on each bolt in a cross pattern until you get it snug down, and give them a good snug pull. When you got them tight, then you're going to have to, this will, by friction, will hold it in place. Take your bolts off, and then you can put your bolt lockers on, and then use your torque wrench and torque all these bolts down to 71 foot-pounds in three sessions, like 35 pounds, 55 pounds, and 70 or 71 pounds, in that order, in a crisscross pattern. So you're not doing all one or the other. After you got them all torqued to your 71 pounds, you go around and check them again if you feel like you need to, and then the tabs over on to the flat, one of the flats on the bolt, and you'll have them locked in place. Then you're ready for the next step.